Ladies and gentlemen, welcome back to the YouTube channel. Today, using Scilab, I would like to show you how to visualize three-dimensional data. The sample data file is prepared already in text format. CSV means comma space delimited value. And if I open, we can see how it looks like. There is one header line. Defining the column names, and we have 5 columns: the tree number, the X, Y, Z three-dimensional position, and the temperature in Celsius. You can see that the data are separated with semicolon, and the decimal separator is comma. This information we need later when we open the file. I would like to make a user interface for it, because then it's easier to use than just typing in the comments. So I will make a 3D viewer application, and I will save it. Yes, 3D viewer. First, we create the application window. And in the hub, we can see that there are 2 options to create a window for us. It will be a figure. You can use the figure command or the create window. There are slight differences between them. So create application window. I personally prefer the figure command, because with the figure we have more options. I can add, for example, figure size, figure name, the title of the window with one step. So figure size will be in pixels on the screen. Initially it should be 1000 times 600. It means that I plan my user interface with these initial values. The 3 dots at the end of the line means that in the next line I continue and add more parameters. This way we can separate them. It is more readable. I like this style better. So the figure name is the next one. It will be the title of the window, 3D data viewer. Okay, let's check how is it working. I save and run. So now we have a window, but there are many tools here. I don't need them. I will turn off. This is what is automatically provided by the create window. So I don't want this window to dock to the user interface. So dockable, no. I will turn it off. The next one is info bar. Info bar visible, it will be off. Oh, sorry, when I type. Yes, the toolbar visible, it will be off again, and then menu bar, it will be off. Because I want to make a plot, the default axis will be turned on. With the window it is turned off, but I would like to plot a chart. So default axis, I will leave it on. And one additional feature, it is very useful. When I resize the window, I want to scale automatically the figure inside. It means that the auto resize, it will be also on. So this is how the figure is created now without any other things. And here at the console we can see that menu bar, I made a typo mistake. This is why we always have to check menu bar visible off. Okay. I will turn off the warning messages for function changes, because we will create functions and modify them, and the function protection I can turn off. So I just would like to avoid always the warning messages. Because I know that I changed the functions. The function protection I turn off now. Be very careful when you do it. Don't overwrite any useful function. We just do it for ourselves. So the user interface will be in the handle session. I will save everything in the handle session, whatever possible. First create it with a dummy, and after that I will make a chart frame to plot the data. Handles chart frame. It will be a user interface element. The user interface controls we can see how to create, and the control properties we can check how much parameters we can adjust. But first I will make a frame. You can see that the type can be a frame. So the chart frame will be a user interface control element inside F figure, because I created the F figure on top. After that, what to do? The style will be frame. I have to specify where it will be, and the units can be pixels or normalized. I will use normalized units. It means that everything will be from 0 to 100%. So the position, when I say where the frame is, will be 0, 0 from origin to 0.8, 80% of the window and 100% of the window. It means that initially I will have an 800 times 600 chart area. Yes, it is, and I still left 200 pixels ribbon on the right side to put push button, sliders, whatever later on. Okay, first I would like to read my data, so I need one more element on the user interface. So the handles will be extended with a push button, pb open. I give the name because it will open a file. It will be user interface control for F figure, and basically I can copy things from the top. I'm lazy, I don't want to type too many things. It will be a push button in style, and I can also say what will be on the bottom, what text I will see, what will be the caption. It is string and open CSV file. This is the text on the push button. The position should be different because it should fit in the 20% left on the right side. So it will start at 82%. I leave 2% around. 90% in vertical position, and the width should fit in the remaining 20% minus the 2% at the beginning and at the end. So basically it will be 16%, and 0.06, it is a magic number, but this was working for me to fit the text. You can check how it works on your screen. So now we have a push button, the text on it, we give the position, and we need a callback function. What function should run when we click on the button? I will call it similarly to the name, pb open, and there will be the parameter of handles the session. Okay, so basically I will have a push button. When I click, the pb open function will run. Now I have a push button, but no function yet. So we have to write a function to give functionality, to give action to it. Functions. The first function will open data file. So it will be called function. And pb open handles. You can see the function is automatically offered to me. What shall I do? The user interface get file is a command we can use to get a dialog box, a window to select file, and you can see that the answer will be a list of parameters, the file name, the path and the filter index. So file name, path, filter index. Filter index will say which element was chosen finally from the list of files. If it is 0, no option. We cancel it. So user interface get file. And what should be the mask? It has two parts, always the file mask and the name. So it should be in a list, sorry. And first we need CSV files, but in Linux and Unix capital and small letters are different, so I make double, and CSV data file, comma space delimited value, CSV. We can see that we can choose a file, but if the filter index is 0, no file was chosen. So we can check that somebody just cancelled, then we don't have to do anything. I will give a warning message that no file was selected. We can create a message box with the message that no file was selected. The title should be an error, because then we cannot do anything, no data to process. It is an error type box. And modal, it means that cannot click on the Scilab other parts until I answer to this dialog box, and then return. We can check whether it is working. Any new warning message? No new warning message. And if I click, the dialog box appears. Cancel, yes, no file was selected. Perfect. This is what I expected, how it works. Now we can load the data from the file, what we observed. The comma space delimited values can be read with CSV read file. We can retrieve information. You can see file name, separator, decimal, we have to set up for sure. And at the very end, there is the option to give the number of the header lines. So unfortunately, we need this. So the conversion, substitute, regular expressions range, we also have to specify or leave them open, leave them empty. So CSV read. We have to read a file. What file? It will be a full file name, including path and file name. So with full file, we can check how it is working. Full file. You can see that full file here. With a path and others, it is just concatenating them to get a file name. So we have a path and we have a file name. There we give a full file. And what we need in CSV read, we need a separator. The separator was semicolon, as we have seen. The decimal separator is the next one, was the comma. And after that the conversion comes. We need numbers, so double, and after the double numbers, because I don't want to read text, I need numbers. I don't use the three parameters, three options, so first, second, third, and then one header line to skip. That's it. And of course I save the data table. The handles, my data will be this temporary data. Because we are using data from the session, we need also some default values. So my data initially will be zeros, and because we had 5 columns, one row, 5 columns will be the initial, let's say, empty data set, just in case if something happens, we still have a data set to produce, so we will not have an error message because of that. And after that, we read the data. Of course, we have to keep the session alive. Don't finish the program because we will click the buttons to do things with the data. So save the session for later use. It means the handles will resume and keep alive. So we can check how is it working. No message, no error message, no warning, so I didn't make mistake in typing. I can choose the data file and voila, nothing happened because I didn't show the data. Wow, so you can see no error message, no warning message. I have to add one more function to plot the data or show the chart. So I will create a show chart function which is using the handles session and the data saved in it. So plot 3D chart function, it will be show chart. This is the name of my function. And what I have to do first, I need the data. It is saved in the session with the name of my data. And after that, I have to prepare the chart frame we have created already, but we need new axis inside. My axis, where the figure will be, new axis inside the chart frame. The chart frame has the name of handles chart frame. I just copy, then there is less chance to make a mistake in typing the name. And after that, we will clear the figure, the chart frame, and what to do? Just plot the data. What kind of data? The X data is in the temporary data file table, all rows, column number 2. The YD, similar, the temporary table, all rows, column number 3, and the Z position of the measurement points are all rows, column number 4. And after that, we can plot. The plot function will be the scatter plot, scatter 3D. You can see X, Y, Z and other parameters, so this is what we will use. Scatter 3D, and we have X data, Y data, Z data. We finish and save the session because we would like to continue with maybe manipulating the chart later on. So after this, the figure should appear. I save and run, check the data, and yes, I have a figure. Unfortunately, it is not really interactive. Even if I click, nothing happens. So I will add some modification here to be able to rotate this figure. I will use sliders on the user interface, and then I can make new viewpoints. To be able to do that, first I should get the information what is my chart now. So handles my figure will be the current plotting area. Sorry. And after that, we can also define what is the current viewing angle or viewpoint. Copy. Rotation angles. Sorry. Always automatically doing that. And I can give two numbers. What should be the viewpoint? It shouldn't be a constant value. It's better to have parameter from the session. So handles angle number 1 and handles capital angle number 2. So if we define these values, we can use here to rotate our chart, and I will give to the default values angle number 1 is 60 degree and angle number 2 also 60 degree. Without doing any rotation, just manually defining, you can see that it is different. So basically these angle modifications are working. And now I would like to add sliders to the user interface to be able to manipulate the position, how I rotate the figure. So handles should be an info text for the rotation. The first info text, user interface control element for F figure. What it should be? It will be a text. So the style is text. The content is a string, and it should be horizontal rotation. Then I need its position. And you can see that I would like to put it below the push button, let's say 80%, because 8 plus 6 is 86, still below the position of the button. So this is the info number 1. And of course I can make a second info text later for the vertical position, the vertical rotation. But it will be later. First I create the slider. So handles slider horizontal, because the first was the horizontal. It will be a user interface control element for F figure. And then what can I do with the slider? I should check the user interface control elements and the control properties. You can see here that, for example, minimum maximum values are specified for a slider, which are the ranges. Of course, there is a value, a current value, and so-called slider step. So these are the additionals compared to the previous setups. So I will have here one style which will say that I have a slider. The tag of the slider, how I can refer it later on, maybe should be slider age, similar to the name, and then what I need, the position, it is below. Okay, if I minus 6, then it will be 74. It will be below the text, right below. Then come the parameter list. The minimum angle, viewing angle, should be minus 30. Oh, sorry, minus 30. The maximum, let's say 90. The current value, like the initial I set up here, it will be 60. Oh, no. It is value. And then 60. And then the slider step, how it will react when I change the slider, for example, with arrows, with keyboard. Slider step. If it is not automatic, I can define 1 and 5. And I also need a callback function. What will happen if I interact with the slider, modify the value, the callback, what I want to do, I want to rotate the figure rotate using the handles session. Okay, so basically the slider seems to be ready, and I will copy down to have the vertical slider. The second info box will be used for the vertical slider. 74 minus 6 will be 86. So this will be the vertical, just below the other. And now comes the second slider. It will be slider V for the vertical position, slider V. And 68 minus 6 is 62. And then basically we are ready now. We will have two sliders. Let's say on the user interface we have two sliders. Any warning message? No. So basically it seems to be okay. Yes. Now we need the rotate function. We have to create a function to rotate the chart. Function, and the name of the function will be rotate. So you can see that we already saved the current viewpoint and the rotation angles. So the handles angle number 1. The first will rotate vertically, the second horizontally. So handles slider V, just to check what was the name, slider V is for vertical, it is angle number 1, and its value we have to use. And the same applies to the second angle, just with the horizontal slider, I get the value, and then I can just copy the line from above, and now the rotation is ready, and save the session for further manipulation. It seems that the rotate function is ready. We check how is it working. Open the data. Okay, it looks nice. Any error message? No error, no warning. It looks nice. Does it work? Yes, I can rotate the figure. You can see that the x-axis is changing from 3 to 0.8, approximately 2.5 meters, the other 10 meters. So basically, if I want to make it proportional, maybe this view looks proportional. Okay, now I can see the three-dimensional location of the measurements, but we measure the temperature, so the Celsius information should be visualized somehow in these positions. Unfortunately for that, we should use colors, but this 3D scatter plot doesn't have nice color mapping like a surface plot. So scatter 3D, you can see we can add some more information. For example, the size we can modify, no need. The color we will do later, and we can also fill. That makes already some sense, because then we don't have just circles, we will have discs. Okay, now it looks at least a bit better. And you can see here the three-dimensional point. Now everything has the same color. What colors we should apply here? You can see some nice color maps. For example, jetcolormap. It will return you a color map with given number of the elements, at least 3. With red, green, blue color coordinates we can substitute here. The problem is that when we want to do it, we have to scale our data to fit the color map and then specify for all data points, not just the color map. Wow, we have to change a little bit. So make a color map for data. Our data will be in the temporary table column number 5. And if I want to get any color index, it is possible that, for example, floor round down the values. I will make 10 times, It means that I will scale from 0 to 10. What? The value minus the minimum value and divided by the range, the maximum minus the minimum, it will scale it automatically to 0 to 10. So the difference to the minimum proportional to the range multiplied by 10 will scale everything from 0 to 10. Okay, but we have no 0 element usually in Scilab, so the first element has the index number 1. So this is the reason why I gave 1. So the color map, I need jet color map of 11 pieces, because 10 plus 1 is 11, and you can see that the jet color map will be nice blue to red basically. Okay, we have the colors, but we need color values here, what we can substitute the empty space here. We need color values. The color codes will be at the beginning zeros. How many? The length of the data and 3 columns, because red, green, blue intensities are inside. So in a cycle, for loop, we will run all over them and specify from first to the last length of the data. Each element in the color codes with the index number I will get from the color map a value. Which value? According to the color index. The color index was created for all data what we have, and we need always the columns. So because we have matrix, one row will be replaced with the other row from the color map, and now we can get the color codes, and the color code will be a list of red, green, blue intensity values. Wow, let's check how is it working. Okay, it seems I didn't make any typo mistake. What happens if I open the data? Wow, it has colors. It looks beautiful. So now we can see the color is changing from minimum value to the maximum value. The minimum is the darkest blue and the highest is the darkest red, and between you can see how the data is changing. Okay, and because everything is in normalized coordinates, you can see that even if I make full screen, it will automatically keep the proportional size, or if I get it smaller. Okay, so this was the functionality what I wanted to show you, how easy it is to make a user interface in Scilab and showing the three-dimensional data, even if it is not only the three-dimensional position what is important, but we have three-dimensional coordinates and the measured data. The 3D scatter plot has some option to make coloring, but as you can see, we need a small hack to run it. Okay, thank you very much for your attention. Have fun with Scilab.